I am defining one function f1. Here I am taking as a normal argument, arbitrary argument, and kw arguments. Print of x, type of x. Next one, print of y, type of y, print of z and type of z. Now I am calling f1 function. At the time of calling the f1 function, we are not passing any value. Very clear? Now observing very clearly, x is a normal argument and y is a arbitrary and z is a kw_args. But at the time of calling the function, I am not passing any value. But x is a normal argument, compulsory one value is required. Now f1 missing one required position argument x. Okay. Next another example. Here I am passing 3. Now this 3 passing to x. Now type of x is integer. This is arbitrary. It takes 0 or more arguments. By default type is tuple. This is a kw_args. It is also taken as 0 or more values. By default type is dictionary. There's another example. OJ false 9. A is equal to 29. Now observing very clearly, the post argument is passing to post parameter x. Next, this is arbitrary. It takes 0 or more values. These values are passing to y. Now this is a kw_args. These keyword arguments are passing to z. Completed. Now here I am taking as a star x. Okay, here star x is a arbitrary and y is a normal and this is a kw_args. Now this is a post argument. That's why these all elements are passing to x. These values are passing to z. But here y value is missing. Okay.
So could you repeat once again?
Okay, this is arbitrary. Arbitrary takes 0 or more values. These all values are passing to x. These are the keyword arguments. These values are passing to z. But here y value is missing. Now my requirement, I want to specify the y value. That is a keyword arguments concept. Now simply we can assigning y equal to 9. First we can assigning all the non-keyword. Then only we can assign the keyword arguments. Okay, by mistakenly, I am using this format. This is a KWR. This is a normal. This is a arbitrary. Okay. Next one. Here I am taking as a arbitrary. Here I am taking as a normal. Again, we will get the error message. Don't take post argument as a KWR. First, we are taking as a either normal argument or arbitrary. Next one, variables. Variables are used to store the data for future purpose or future use. The variables are used to store the data for future purpose or future use. Procedure oriented mechanism. In procedure oriented mechanism, the variables can be categorized into three types. First one is local variables. Second one is non-local variables. And global variables. Local, non-local, global. First one, local variables. You can define a variables within the function or inside the function. The type of variables are called local variables. We can define a variables within or inside the function. The type of variables are called local variables. Next one, we can access the local variables data. We can access the local variables data within that function only. Within that function only. We can access the local variables data within that function only. F1 of x, that is the local variable. Next one, we cannot access the local variables data from outside of that function. We cannot access the local variables data from outside of that function. Now here we cannot access. Next point, we cannot access the local variables data within another functions. We cannot access the local variables data within another functions. Here I'm defining one more function. Completed. Next one, global variables. You can define a variables above the function definitions or at the beginning of the program. The type of variables are called global variables. We can define a variables above the function definition or at the beginning of the program. The type of variables are called global variables. We can access the global variables data anywhere in our program. Above the function definitions or beginning of the program, I am defining one variable. Now that variable act as a global. We can access that global variable data within the function f1, outside the function f1, and within the function f2 also we can access. Next point, in Python, directly we cannot modify the global variables data within the functions. In Python, directly we cannot modify the global variables data within the functions. Here I'm trying to updating x value. Then immediately we'll get the error message. Unbound local error. Local variable x referenced before as assignment. Next point, if we want to modify the global variables data. If we want to modify the global variables data within the function by using forward declaration mechanism. If we want to modify the global variables data within the function by using forward declaration mechanism. Global space, global variable name. That is a syntax. Once we can modify the global variables data, that is affected in remaining all other cases. Once we can modify the global variables data, that is affected in remaining all other cases. Global space, our global variable name is x. Once we can modify the global variables data, that is affected remaining all other cases. That means here we will get the output is 10 plus 5 or 10 plus 15 value or 10 plus 5. 10 plus 5, 15. Next one, here also we are getting the 15. Here also we will get the 15. Next one, non-local variables. We can define a variables in the outer function above the inner function definition. We can define a variables within the outer function and above the inner function definition. The type of variables are called non-local variables. We can define a variables within the outer function and above the inner function definition. The type of variables are called non-local variables. We can access the non-local variables data we can access the non-local variables data within the outer function. That means we can access the inside the inner function and outside the inner function. Here I am defining one function f1. Here I am defining one variable x equal to 10. This is a non-local variable to f2 function. Print of x print of x print of x. Right. Now this variable act as a local to f1 and non-local to f2. Completed? Okay, here this is a non-local variable. We can access this non-local variable within the f2 and outside the f2. But outside the f1 we cannot access it. That's why here we will get another message. Next one in Python. Directly we cannot modify the non-local variables data within the inner function. Now observing very clearly here I am trying to updating x value within the f2. Now unbound local error we are getting. Completed. Next one, if we want to modify the non-local variables data within the inner functions by using forward declaration mechanism, syntax non-local space non-local variable name. Once we can modify the non-local variables data that is affected in remaining all cases. Non-local variable name is x. Now initially x value is 10, 10 is printed. Now x value is updated. Now x value is 15. Here also we are getting the 15. Here I am taking as a x value 10. I am defining f1 function global x y equal to 20, x plus equal to 5. Now def f2 global x non-local y and z equal to 30 print of x print of y and the print of z. X value is updated, y value is updated, and the z value is also updated. Outside the f2 function, x and the print of y, I am calling f1 function and the print of x. Write this. Here x is a global variable, y is a non-local variable, z is a local variable. Now observing very clearly, first one, the statement is executed to allocate the memory space for x variable. Now control go to the statement, this is a which statement, function definition, then immediately control will go to here. This is a outside the function definition f1. Now this is a which statement, function calling statement. Again control go to function definition f1. Now function body logic is executed. Global x, y is allocating the memory space. X value is updated 10 plus 5, 15. Now x value is 15. Next one, this is a which statement? Function definition F2. Control will go to this one. This is a which statement? F2 calling. Control go to F2 definition. Now this logic is executed. Here print of x. What is the x value? X value is 15. Y value is 20. Z value is 30. Now again x value is updated. 15 plus 5, 20. Y value is updated 20 plus 5, 25. Z value is updated 30 plus 5, 35. After executing these statements, now again print of x. What is the x value? 20 and y value 25 and z value is 35. Next counter will go to here. Now print of x value 20, y value is 25. Again control go to here. Now what is the x value? 20. X value is already updated. Now that is the output. Next one, scope of the variables. In Python, the scope of the variables are following. Python, the scope of the variables are following. LEGB rule. First priority local, next priority enclosing, that means non-local. G means global and B means built-ins. Local, non-local, global, built-ins.
Sir, what is built-ins? That is part of global built-ins, right?
Global is different and built-ins is different.
Okay.
Now I'm taking as one variable. Defining F1. Next one here, I am defining y equal to 200 and z equal to 300. The F2 I am taking z value is 3. Print of x, print of y, print of z. Print of x, print of y, print of z. Okay, this is a which variable part? This is a global part. This is a non-local. Now this is only local part. Now observing very clearly, I am trying to execute in this program. First, these three variables are executed to allocate the memory space for these three variables. Next, control will go to this statement. This is a which statement? Function definition. Then immediately control will go to here. This is a which statement? Function calling F1. Control go to function definition F1. Now function body logic is executed to allocate the memory space for these two variables. Again, control go to here. This is a which statement? Function calling F2. Again, control go to F2 definition. Now F2 body logic is executed to allocate the memory space for Z variable. Now X value. First one, we need to check X is available in the local part. In the local X is not available, go to non-local. The non-local X is not available, go to global. The global X value is available, that X value is 10. Next one, Y variable. First we need to check the local priority. Locally Y is not available, go to non-local. Non-local Y is available. Now that Y value is 200. Next one, Z. Here Z is locally is available. Now Z value is 3. Next one, function execution is over. Control go to the statement. Now this scope will only access the F1 variables. Don't access the F2 variables. Because F2 is a local variable, its Z value we can access only within the F2. Now print of X means what is the X value? 10. And Y value 200. And the Z value. What is the Z value? 300. Okay, here we cannot access this Z value from outside the F2. Here only two Z variables are available, this one and this one. First priority, this local one, that's why Z value is 300. Next one, outside the F1, we can access only global variables data. Print of X means 10. Next print of Y means 20. Z value is 30.
So if the variable is not there in global, then it will go to built-ins also.
And the built-ins module, that variable is available, that value is existed. Or otherwise, we can give the one error message.
Okay.
Just one more example. For suppose I am defining one function. That function I am defining one more function, sum function. Calling calculation. Next one, print of. Now observing very clearly, I am calling calculation function. Control will go to calculation definition. Now this is also function definition. Control will go to the statement. This is a which statement? Function calling sum. Now locally sum function is available. Now this logic is executed. What is the purpose of this logic? Just to print X value. What is the X value? 4562. After executing this function, control will go to the statement. Now here also I am calling sum function. In that situation, this sum function we can access only within the calculation function. Outside the calculation function, we cannot access the sum function. Now first we need to check globally sum function is available or not available. If it is not available, go to built-ins module. In that built-ins module, some function is available or not available. In that one, some function is available or not available. Okay, some function is available. This function logic is executed. The purpose of this function is to print the sum of the given list object elements. Now here we give the output as a 4 plus 5 plus 6 plus 2. 9 plus 6, 15, 15 plus 2, 17. Okay. Here our own function is executed. But here built-in function is executed. Completed. Okay, next class we will discussing a remaining continuation.